Hello everyone, and thank you for joining us today. Just so you are all aware, we will be starting the webinar in just a moment. We're just going to allow a bit more time for people to join. So thank you for your patience. Hello everybody, my name's George and welcome to our latest webinar, where today we will be talking about the future of the solar industry. To explore the topic in depth, I'm delighted to say that I'm joined by Jason Kirridge, Technical Marketing Manager at Solaredge. Good morning to you, Jason, and thank you for taking the time to be here today. So in just a moment, I will be handing over to Jason to kick off the presentation. But before that, I'd like to mention that we will have some time allocated at the end of the session for audience questions. So please do stick around until then, and we will make sure your questions are answered. To ensure that we see these, please type them in the questions box in the bottom right-hand corner of the screen. Without further ado, I will now pass over to Jason.
Thank you, and good morning to you all. Looking forward to this presentation. I hope you enjoy it as much as I do. So, first of all, what we're going to cover today is all the exciting stuff in the future of the solar industry, in particular what Solaredge is going to give you. So, let's go on to the first slide. So electrifying heating, mobility and heat pumps and EVs have basically been the watchword for the last couple of years. And we've seen the energy market change almost overnight. People are using more energy than they've ever done before because of EVs and heat pumps. And it's reached a record-breaking limit with 1 out of 5 cars sold globally are now electric vehicles. So the increase of this electrical power as a source of energy by using clean methods to generate this electrical power has led to more solar PV installations being installed, more ground mount systems being installed, and the decentralization of transmission of electricity to more of a virtual power plants. So what you can see here is the original centralized image where you would have power stations will be built around coal production sites, so mainly the north of England, with coal then being moved around to power stations to, on the right-hand side, the decentralized, which is basically a home, which is now becoming a virtual power plant. So your own home has a battery, your own home has PV. This enables you to be self-sufficient throughout most of the months of the year and hopefully leading to a reduction in cost of your energy prices. So what's has to have happened to enable you to do this is that products have had to evolve. So rather than just a dumb product that switches on and off as you tell it to by a press of a button, you've got to have software-controlled products. So all your products have got to talk together. Your EV's got to talk to your inverter to see what excess energy is available. Your battery has to talk to your inverter. Your smart devices, hot water devices also have to talk to each other. So most of these are going to be by the same manufacturer, and it's often preferred to have the same manufacturer doing these products, as it just saves confusion and you end up having several apps. These are all going to be software controlled. And then you've got an issue with cybersecurity. Now, the regulations in the UK are changing. I think it's April this year, and I'm pleased to tell you that Solaredge are well ahead of the cybersecurity is needed, and we will be able to issue a statement probably in February saying exactly what we comply with, how we comply, and as Solaredge users or future Solaredge users, you should have no problem with that. So this is the Solaredge home. as I said, we have, it's better to have a manufacturer that does all your products. And you can see on here, we start at the very top with our power optimizers and also our smart modules, which is a module from Solaredge with a power optimizer attached to it. We've then got on the 9 o'clock position, we've got the inverters and batteries available to you. So we have a residential range of 3-phase and single-phase products, each with a battery available for the 3-phase and single-phase and backup interfaces as well. Then moving on to about the 7 o'clock position, you've got EV chargers. We've got the DC EV charger there and the AC EV charger there. And then moving on to around about the 4 o'clock position, you've got your load controllers. So you've got hot water diverter, a load controller for your heat pumps, plug-in sockets to control loads, and also an inline controller as well. So you can put that in something like a towel rail or a heater. Then the inline meter as well. And then underneath you can see with the new label on it, we've got the Solaredge home load controller. I'm going to talk about that now, the next couple of slides. Just above that, you've got your My Solaredge app, which basically will control all of these. One app, it will control your EV, your hot water, your PV inverter, and so on. And you'll be able to see the production of every single one of your modules on there as well. So what we have is 3 different types of rates. We've got a fixed rate, which most of us have been on from day one, and then the time of use rate, which came in probably about 2016, where you could sign up for a cheaper rate electricity at night, a bit like Economy 7, and then in the day you would pay a slightly dearer rate, but you would hope that you would save all your energy during the night and you would be able to use that during the day. And then the next one is a dynamic rate. Now, a dynamic rate is a new one, and that depends on what's available. So there might be an excess at the power station, and then they're giving away this electricity free. And what you want to do is use that to charge your batteries, to charge your car, and then not to import from the grid on the dearer times. So we've got 2 colors here. We've got blue, which is the blue is the import rate. And then we've got orange, which is the export fixed rate. So you tend to get pay more for your electricity than what you actually export it for. You have an organization called the European Power Exchange Spot Market, and they set the prices for the whole of Europe. And these could be changing every 30 minutes or so. So they do the prices for gas and for electricity. And most countries have time of use rates, so the United Kingdom, Germany, France, most of the EU countries, and then also dynamic rates. So the United Kingdom again, Sweden, Norway, Finland, and so on. They have the dynamic rates. And this means that you're able to control exactly what you do with your energy that you purchase or the energy that you have as excess. So what you can see on here is a full year, and you can see how the rates have changed during that year. So every day seems to have a different time of use rate, a different value, price adjustments according to summer and winter. And all of these are happening in the background. And what we want to do is to make use of these to basically make your life as easy as possible, and to stop you spending as much money as possible. So as a homeowner, how do they do this? I mean, what do they do to solve this problem of dynamic rates and all these devices in the home that import electricity, and there's no control over them? So we've got this new product coming out, which is the Solaredge 1. And it takes the complex decisions that you have in day-to-day of when to turn stuff on, when to turn stuff off, and how long for. And it looks at the import prices, looks at the export prices. It works out very, very quickly using your actual day-to-day usage, the history that you have, what you would use tomorrow, making sure your battery was full, or whether not to charge your battery at night and to use the excess PV. And it does all that for you. It basically integrates with third-party controllers, so heat pumps, things like that, and it controls them and tells them when there's excess energy or when the cheaper rate to turn on, and it basically runs your home for you to avoid you importing from the grid at the more expensive rate, and to harness the fluctuating dynamic tariffs that we have. So it does it in three ways. It takes all the information, so the external data sources. So this could be prices in your particular area, different tariffs in your area. It then looks at what you actually do with your energy, how many devices turn on and off, what your predicted habits are. And then it looks at what your actual preferences are. So you want to charge your car at a certain time, you want your battery on at a certain time, you want to do your washing, your drying and things like that at certain times. And it takes all that information and then it optimizes it together. So it takes it all, works out what the best pattern is for you, and then it implements it. And that would be on battery control, load orchestration, backup management as well, making sure you have enough in your battery should there be a backup event. And also the option to sell back to the grid as well when your battery is full and the grid require extra energy. And we've got just a couple of screenshots here. So your external data sources, this would be from utility tariffs, energy markets, weather data as well. Weather's very important, obviously, for if you have PV, because a couple of days ago I had snow all over my modules and it was a beautiful sunny day, but I couldn't produce anything. Next day, snow had gone, but it was a miserable day. So weather is really important as an external data source. You then got to look at the internal data sources. So this is the Solaredge monitoring here. It gives you a historic map of what you've done, what you've actually produced, what you consumed, and what patterns. And the patterns are very common. You can see that most things are done in the evening, cooking, during the morning, early in the morning, people turn on devices before they leave for work, maybe dishwashers, things like that. And then you also have your the flow from and to the grid, and what your battery is doing and so on. So this is part of the internal information, and then your preferences. So what you want to do with your battery, what you want to do with the excess solar you have, the backup reserve that you set. So generally the default setting is 30%, but you can drop that down to 20%. And then your essential devices. So if you have a backup event, what essential devices do you want to work? Do you want your EV charger to work? Well, yes, it can do, but then it may drain your battery very quickly. So you could be able to turn off all your smart devices and actually tell them whether you want them to be an essential device or non-essential device. So you get basically a 24-hour a plan which is optimized, and it then delivers to your home, making sure that you are getting the most you can out of your system, and hopefully you'll be very, very happy with it. You also remember your 24-hour energy plan is slightly different. You've got different habits, different weather formations as well, takes this all into account. And the last one, the most important graph here, is basically the house is powered from the PV using conventional MSC between 11 and 3 p.m. And then we power the home from the grid and use PV to charge the battery at 4 p.m. So you can see the different colors on there. If you look at the very bottom line, that's the battery graph going up and down. That's the battery SOE. Then you've got your import and export in the middle bit, and you can see which one is which. And then you've got your PV production, and you've got different color lights on there as well. Anything that's orange or red is importing from the grid. Anything blue, light blue, green, light green, dark green is coming from your PV and your battery. So what you would do is, if you reach the end of the day and you haven't used everything in your battery, and there's an option for you to discharge your battery into the grid using a DFS scheme or something like that, you'll be able to do that. So it takes into account the lower rates during the day, the more expensive rates as well, and then basically controls and optimizes your system to avoid you importing at the more expensive times. And again, as I said, execution is it uses the inverter to export and import. It uses the battery again to charge and discharge at the right needs, and the load orchestrators for the PV, smart home, hot water, and also the load controller for things like heat pumps and third-party devices. So this is the Solaredge Home Local Controller. It's coming soon. We'll probably, the name will be changed to Solaredge Residential 1. As you can see on there, it supports local EV integration, heat pump, and smart home as well. So the functionalities, what should it have? Well, it can interface to the local network infrastructure and the site interfaces. With third-party appliances, using either local connections or the cloud connections. It can communicate with Solaredge again, using the One app, so you'll see everything on the third-party devices will all be on the Solaredge app. You'll be able to see that quite clearly. And this is basically the plan. So during the day, you have a new day begins, you have your energy saving mode, you look for your new prices, you have your peak prices set, you have your peak prices anticipation, when you expect it to be dearer, to be cheaper, again your low batteries, and your homeowner, if your homeowner works from home, your EV is charged directly from excess PV, trickle charge, which is ideal. You basically put that in all day and plug your car in all day, and it just does it automatically for you. And then 6 o'clock in the morning, you've got your peak prices where it's expensive. And if you've got battery left over, that will go into that there. So it manages your home for you, giving you the 24-hour plan to run your home. This is just a recap. Just say that it takes all the information again from external, internal, and homeowner preferences, puts them all together, extracts the best plan it can do, and executes that with all your devices, including third-party devices. So you have the EV chargers, heat pumps, solar PV, and battery as well. Now, moving on, we're looking at the DFS, which is a demand flexibility scheme. Now, we did this last year, and you may have heard me mention in the previous slides, we talked about selling your battery basically onto the grid. So this was last year's one, which was January to March 2003. It was a trial. It worked incredibly well. We had lots of subscribers, and people opted in, and the organizers then took over their battery, charged it using PV excess or charged it from the grid, and then discharged it during a peak event, and then after the event allowed it to charge again. And that's basically the mechanics of it. So what were the incentives? Why did they do it? So the National Grid, they didn't have a risk of blackouts. It wasn't like things were going to go off. But it was just a question of, rather than starting power stations up, they could use the energy that was already in the batteries all around the country to feed back into the grid. So it smoothed out the demand period during peak hours. You know, like during a football match, half time, everybody runs off and switches on the kettle, and then they come back in, make a cup of tea, and what have you. And that's basically what it was. There was a huge unpredictable demand, and rather than firing up the power stations, they could simply just release energy from the batteries to local areas. And then you've basically created your virtual power plant, which is what we spoke about first off. If you were a homeowner and you took part, it was up to, as it says here, 10 times more financial rewards. If you work out that you pay for, let's say 15p or 30p a kilowatt that you import, and you're being given £2 to £3 per kilowatt. So if you have a 10 kilowatt battery, let's say that's £20, and it's costing you £3 to charge it. So you're making £17 profit. So it's really a no-brainer as such as to why you would do it. So then we decided, let's do it again, and we've opened up the registrations for December, and we are going to keep this open. There's no end date for this, so please sign up for it. There will be 6 events between November and December. There will be 6 events in January and March. These are guaranteed events. There will be more, but these are the minimum. So you have the option of earning, if you did all 6 events and you had a 10 kilowatt battery and you were being paid £2 a kilowatt, that's £20 per event. And there's 12 of them. That's £240, if my memory or my maths is correct, that you could earn. So it's a very good opportunity. Now, I also spoke about having everybody from the same manufacturer. And the reason this is very important, or the reason that you have a controlling device is very important, because of G100. Now, G100 came about on the 1st of May in 2023, and it's slowly gathering steam and momentum, and DNOs are now asking for it more and more. DNOs are giving you information. DNOs are refusing applications because your particular devices are not G100 compliant. The whole purpose of G100 was to control the import and the export. So prior to the 1st of May, we had G100 Issue 1, which came about in 2016, which controlled the export. So that's what you put back onto the grid. Now, the grid is worried about what you're using from the grid with EV chargers, heat pumps, and so on. So they basically decided that they want to have a device on every single home that limits the import to the grid and controls smart devices. So things like EV chargers, batteries from AC coupled batteries from AC charging, such as time of use or dynamic rates, which we've just seen. Smart devices for hot water, heat pumps, and things like that. And if you did import too much, rather than your main fuse blowing, what it would do is it would go into the lockout mode. So it has 4 states, which we'll see in the next slide. And it has a normal operation, an occasional excursion. So if you exceed something for 15 seconds, that's called an excursion. So if you lose communication with a device, it has to go down to 0 if you lose communication for 15 seconds. And then you end up with a failed state where a device is imported and exported less and it switches off. And then the very last one is devices switch off for a period of 4 hours. There's nothing you can do when you get to the last stage. It just has to run its internal timer. You can't turn the stuff off and turn it back on again. The limits for this are set by 2 people. The first one is the export limit is set by the DNO. If you have a G98 application and you install a 16 amp inverter, it doesn't need to have an export limit set for it because it's 16 amp inverter. However, if you install a battery with that or an EV charger on that site, or if you install a smart device for hot water heat pump, then that imports from the grid and that needs to have an import limit set on the device. Now, if you have a look at the drawing and you see from the right-hand side, you've got a way of measuring the import and output to the grid. And you can see that's in amps now rather than watts. You then have a device which able to control everything that's going on. And that controls the storage devices, it says there, generation devices, and controllable loads. And these are your smart loads. So why is it important that you have the same manufacturer? If you have 4 different manufacturers supplying 4 different products to someone's home, you will need 4 different devices to control it. And we all know from experience that different devices don't work very well together. We've seen it before where hot water devices don't work with someone's PV device, or someone's AC coupled battery device doesn't work very well. So if you've got them all on the same manufacturer, you've got no problem. But if you haven't, then you could end up having a very upset customer, because the worst case will be that some devices never turn off, some devices never turn on, and some will be working on and off all the time, causing you massive problems. So we strongly recommend that you use one manufacturer. And as I said before, the Solaredge Home, we have all these devices as part of it. If you want to find the actual documentation, you can go to the ENA Type Test Register. It's a free site. You don't need to log in for it. You can sign in as a guest. You search Solaredge and you will be given up to, I think it's 198 certificates. You search for the one you want. You can filter for the size, and then you can either give the blue reference number here, or if you want, you can actually click on that number, and it takes you into the certificate itself. And then you can see on there, you've got the actual type test certificate. You've got the cybersecurity document. Remember, I mentioned about the cybersecurity rules are changing this year. And then you've actually got the G100 issue to amendment documentation. And you can simply give the reference number or download all these forms and send them off with your application. This here covers all the devices. So although it's an inverter a type test register, it does say that it covers the EV chargers, the batteries, and the smart devices, because our inverter is actually the brains of the system. This is what you get. You then fill out your name, address, telephone, website, and email, and send it off to the DNO. This is what it would look like when you're on the setup. You have an import and an export limit. Again, if you've got a 16 amp inverter, you just put 16 amp in there. An import limit will be set by the size of your main fuse on your property. If you do have a lockout, and you will probably get a lockout the first time you commission it, you simply click on the top bit there and then press unlock. Now you'll be able to do that, the homeowner will be able to do that with My Solaredge app, but if they have repeated lockouts, it will go to the stage 4, which is a 4-hour lockout. So on to the exciting bit here. So Solaredge Home DC EV Charger. Different from the AC EV charger, as this one goes on the DC side. As you can see on here, it's 12 to 24 kilowatts that we'll be able to do, and certificated for all regions. So why a bi-directional EV charger? We spoke about using a home as a virtual power plant. And if you've got an electric vehicle, well, that is a huge battery that you can draw from. So should there be a power cut and you were connected to it using the DC EV charger from Solaredge, and you had the backup interface fitted, you'll be able to run your home from your car. Likewise, you'll be able to do vehicle to grid and vehicle to home as well. It's a more efficient way to do it, because you're not transferring from DC to AC. And also with the large oversizing that you can get up to 200%, it means that all clipped energy will then go directly into your car rather than be wasted. So this is the architecture. You can see we've got left-hand side in red is the DC bus, and the right-hand side is the AC. So we've got charging directly from PV. It should be animated, but it's not. But what you will see is the PV on here in the red, where the sun is basically going directly to the car. Okay. And there's no AC to DC conversions because it's all on the DC side. And then we've got fast charging, which is simultaneously drawing electricity from the PV array, the battery, and the grid. So all those will be available to you. So you can have it running from your inverter, from your battery, and also going to the car from the PV as well. All that's on the DC side as well, remember? And then the lastly is charging the EV from clipped energy. So if you've got a 3.68 inverter, you can install 200% on top of that, which makes it into a 7.3 kilowatt array. 16 amps will go directly to your home. The other 16 amps would normally be clipped, but that would go directly into the EV charger and also would go into the battery. So there we are. That's the end of the presentation. I think I'm spot on time, which is not bad. So open to questions, really.
Brilliant. Thank you, Jason. Yeah, really, really good and insightful presentation with a lot of different topics and areas discussed throughout. And I'm sure there'll be lots of questions in the Q&A section on that as well. Now, before we move into the Q&A section, just to allow more of our audience to get some questions in, I might just ask one myself. So what are some of the opportunities within the UK solar market as opposed to other markets such as, let's say, Europe and the US? And considering this webinar is talking about the future of the solar industry, what opportunities do you forecast for the future?
Yes, so the main one is being self-sufficient. That's what I think people are going to be. Years ago, when we had the tariff, people were interested in selling their electricity back to the grid. Now times have changed and people are becoming self-sufficient. So the secret to it would be to install as much PV on your roof as you possibly can, install as big a battery as you possibly can, harness all that energy and use it for your own needs and also use it for a DFS scheme. Now, whereas it's changed in the future is we've now got heat pumps. So we've got these various innovation grants for insulation, for installing PV. You've also got them for installing heat pumps and things like that. And that's where the future is going. It's going to make your home as efficient as possible. So heat pumps are going to be becoming more of a viable product to install on your home. You need to do some serious thinking about it, but you can do it. So I see the future in the UK as harnessing everything, whereas in other regions that may have a lot of sunshine would heat their water a different way. We don't have that joy, unfortunately, so we would have to use heat pumps or we would have to use heat diverters.
Brilliant, thank you. And I see we've got a lot of questions coming in, so we'll try and work our way through as many as we can. To get the ball rolling on that, Fabian asked, if he does not have a PV, but a heat pump and a battery storage, does it still make sense to sell energy back to the grid, or will it never back off to resell energy that is first purchased from the grid in the first place?
Okay, so if you were to buy your electricity at a cheaper rate than you were to get it back for, then yes, it would make money. If you're looking at, is it a good investment to buy a battery and to do time of use? I don't know what the payback period would be. I would always strongly say if you've got an electric vehicle or you've got a heat pump, put as much PV on your roof as you can rather than charging it from a power station. The whole point of going green is to use green fuel, not to use coal or oil, powered electricity to fund your green product.
Brilliant, thank you. And Jadine asks, could a user/customer override the 24-hour energy plan? Will they incur any repercussions for doing this?
No, it's absolutely free for you to edit and change as much as your needs change. It will give you an optimum plan. If you decide that you want to override that because of your situations have changed, then by all means you can do it. It's not a plan where you are sign up for a fee. It is purely a very good management structure of your home, using all your devices, gathering the external information, your preferences, the actual site, what it does, and developing the best plan for you.
Brilliant, thank you. And there's a really good question from Richard here. So he asked, can the Solaredge One factor in battery management to use the battery in such a way to maximize its working life?
Yes, that's a very good question, because once you purchase a battery, you would believe that it's going to last the time that you've said on the warranty regardless. Now, some battery manufacturers have in their warranty very good marketing, but if you actually boil down and look at the warranty, you will see that they have to have only so many cycles in their life, must be inspected at certain times of that installation, so 5 years, 7 years, and so on, to honour the warranty. And if they don't, the warranty then only lasts for 12 months. Now, I'm very pleased to say that the Solaredge warranty is unlimited cycles. So you can take part in this DFS scheme, you can take part in time of use schemes, and you can have your battery charged and discharged as per the needs of the schemes and your time of use. And you'll have 70% at the end of it. So yes, it's very important that when you look at your battery, you get the right capacity for you. And you also, if you're interested in warranty, and warranty is the thing that swings it for you, look at the warranty document in great detail and see what you will be covered for.
Brilliant, thank you. And Peter asks if the system is it available for 3-phase connections, and what is the maximum storage size installable?
Okay, so the residential Solaredge Home as residential is both single phase and 3-phase. For the 3-phase system, you can have 3 10 kilowatt inverters connected together on the home, and each one of those can have 23 kilowatt hours of battery per inverter. For the residential, you can again have 3 10 kilowatt inverters. That's the largest inverter for residential connected together, and each one of those can have 30 kilowatts of battery.
Got you. And Mariana asked, do you think the price to sell the energy to the grid for domestic installations is going to be increasing in the future or decreasing?
I would say with the dynamic tariffs and the demand flexibility scheme, it will be a very viable proposition for you to purchase a PV system and a battery, and look at, especially if you're at work and you're not working from home and your energy is filling that battery up, and once it's full, it's not going to go anywhere else apart from being wasted or turned into heat. So if you're in a dynamic tariff rate, or you're in a DFS scheme, it will be ideal to do that. It purely depends on you, which is what the Solaredge Residential one does. It looks at what you actually do in your life, in your day-to-day, adjusts for weekends as well, obviously, because they're different from work dates, what your needs are and what the external influences are.
Thank you. And how do you see the future opportunities for Solaredge in commercial installations?
So commercial, we've been around since 2010 in the UK. We had our inverters, commercial inverters, long before I joined, which is 2015. We have a very good range of commercial inverters, rooftop commercial inverters. We have a range of utility inverters, and we also will have commercial storage as well. And that will be the option of being DC coupled. So exactly the same benefits as I spoke about with the home having a DC coupled battery, being able to take clipped energy and export limitation energy. The commercial is going to be exactly the same. It's going to be very, very good.
Thank you. And Paul Cook asked a very good question about the issues of safety and fire safety. So he specifically asked, do you have any statistics on it? But I was wondering if maybe we can broaden this out and just get your view on fire issues and safety with the products.
Yes, it's a very good question. I don't have statistics for it. But I can tell you that PV is installed correctly. It is a safe product to install. But as with everything, you can become safer, as when Volvo invented the seatbelt to make things safer. So Solaredge in particular has a unique technology, unlike traditional technology, where we're able to control the power optimizer, shut the power optimizer down to a default setting of safe DC. The optimizers we have now, the Sense Connect or the S series, have the Sense Connect in them, which detects a build-up in temperature and again stops the optimizer from flowing electricity through a connector, which reduces the possibility of an arc. So Solaredge are the leading manufacturer with regards to safety to PV. We've had that independently tested by the TNO, which is a Dutch testing organization, and they have made a statement, and I'll try and get the statement correct, but they say the Solaredge exceed safety standards within the industry. So we have the safety DC, we have the arc fault detection, we also have the Sense Connect on the optimizer. So we are trying to make the PV system safer than it ever possibly could be.
Brilliant. Now, Julianne asked a question about vehicle to grid. So will that degrade the vehicle battery faster?
It's a very good question. I don't know enough about car manufacturers and their batteries that they use to be able to give you a proper answer, but I would imagine there is a cycle rate and also a warranty rate at the end of that period as to what they would imagine your battery will be worth. So if you're using your car every single day for work and you're having to charge it every day at work, that's at least one charge. There are people that will do journeys that would cause them to have maybe 2-3 charges in that day. So I would say no. I would say it's all built into the design. When you say vehicle to grid and vehicle to home, you're not looking at discharging all your car battery to power your home, and likewise you're not looking at discharging all your batteries. So I don't think it will be a problem whatsoever.
We've got a question here from Rishi as well, quite an interesting one. So are the Solaredge devices using proprietary means to communicate across the ecosystem, or have any standard common protocols been adopted?
So Solaredge have their own communication. It's called the Solaredge Home Network. It's a sub-gigahertz network that communicates to our devices, so to our batteries, to our to our smart devices. The EV chargers themselves connect directly to the router. So we have our own specific communication, yes.
Brilliant, thank you. And Garrett asked, during an extended grid outage, will the system keep generating in island mode?
Yes, that's a very good question, because if you purchase a third-party device that does battery and backup, and then you purchase a third-party PV device, you're hoping that they're going to come on when there's an emergency, but there's no actual guarantee that they will, because they're two different manufacturers. So the beauty of Solaredge is that because we have our own backup, we have our own home hub inverter and our batteries as well, all devices will talk together. So if you have an event of a power cut, and say you set your backup SOE to 20%, and during the nighttime, that 20% is reduced down to 0. Obviously, there's no sunlight at night. So the next morning, as soon as there's some sun and there's some excess PV, that will go back into the battery. So you'll be able to manage your home by not turning on large load devices. You could manage your home and be indefinitely in backup using the PV and the battery to run your home. And should you have a situation where your battery does run down, and we are, say, in one of the northernmost parts of Sweden where you have 6 months of darkness and things like that, there is a possibility that you won't be able to charge from the PV. Your system will last 20 days. The battery will last 20 days. Whereas if you have a third-party device which relies on a third-party backup and battery, relies on a separate PV inverter, as soon as that battery is finished, that's it. You've got no option to charge it. With a Solaredge, you'll be able to charge it from a 0% SOE or from a full battery, or whatever you want, the next day using PV.
Brilliant, thank you. And Ian Wilkinson asks, with a conventional single-phase home supply, is home EV charging just limited by the size of the RI?
So you've got two things to bear in mind. There's a European rule which says the minimum charge is, I think, is 1.5 kilowatts. So if you have excess energy up to 1 kilowatt, your car won't charge from excess PV. But if it's above 1.5, it will charge. So if you're looking at your return on investment is that you're just going to use excess PV, purely depends on the size of your PV system and what you consume as a home. What was the second part of the question?
It was, is home EV charging just limited by the size of the array?
Yeah, so yes, it is. If you wanted to use time of use to charge your car at night on a cheaper rate, you can do that. But you've got to remember your car charges at 7.2 kilowatt, which is roughly about 28 amps, and you're not going to get that off of a standard inverter. Standard inverter is about 16 amps. So you're looking at maybe a 10 kilowatt inverter. You probably have to have maybe 15, 20 kilowatt array for that to give you enough excess energy to charge your car during the day.
Brilliant. And there's a question here asking about the equivalent of G100 requirements in other markets.
Yes, so the UK is a very unique market for regulations and for products, and we've always been the first to start stuff. So G100 is a UK specific regulation. I was lucky enough to be on the working group when we wrote the G100, and it will. There's a great deal of interest from my colleagues in my opposite numbers in various regions. We have a import guard, which you would set on the EV charger to stop you doing just that by importing too much. So G100, I think, will be seen in some form or another across Europe very soon.
Brilliant, thank you. And Julianne asks, what is the maximum size of a Solaredge domestic solar system?
So the maximum inverter we have for residential is 10 kilowatts. For single phase, it will be 20 kilowatt array.
Brilliant, thank you. And Rich asked another question about the G100 certification and asked whether its requirement only pertained to new devices after the 1st of May.
Yes, so it's a very interesting question that people assume that if they're just installing an inverter, they don't need G100. Technically, they're correct, but as soon as they add a device that imports from the grid, so an EV charger, a battery, or a diverter, hot water diverter, or smart device, something like that, you must have G100 compliance. So EV chargers, we had a call with our distributors the other day, and there are lots of EV chargers out there that don't have G100, and they're one of the main the largest current using import device out there. So to be honest, there's a lot of ignorance out there. There's a lot of blasé. I don't really need to know about it until I'm called or not really bothered. But I would say do your diligence, choose a manufacturer that can support the regulations, choose a manufacturer that spends time making sure they meet the regulations before there's a crisis. And before you end up getting into trouble. So take comfort from Solaredge that we have G100 for all our products, and we've tested it and it's been approved and it's compliant for all our products.
Brilliant. So one more question, as I'm aware we're running out of time here, but how does the Solaredge ecosystem work with the customer's energy supplier? Does Solaredge recommend a specific tariff, and how does the tariff integrate with Solaredge in home tech?
Okay, so we don't recommend specific tariffs or companies at the moment. With the dynamic tariffs and the Solaredge Residential 1, you'll be able to select the tariff that you want or is more favorable to you, and that will be managed by the Solaredge Residential 1. It will take into account all the external influences, the internal, your preferences, and will be able to give you the best option. If you're looking just purely at time of use, we have time of use, manual and automatic on the My Solaredge app, so you're able to connect to any system that you want, any supplier you want.
Brilliant. Well, thank you very much. And I think that's all that we have time for today. Thank you again, Jason, for a really interesting presentation and obviously your answers to the Q&A section. And thank you to everyone who's joined us and contributed to this webinar. I hope everyone has a lovely Thursday, and do keep an eye on Current for our next webinar. So thank you very much, everyone.
Yes, thank you for joining, and thank you for your time today.
Brilliant.